Okay, so let's take a look at some log properties for Chapter 7. And there's no handout for this, but the back of the Notes Part 3 handout is blank, so you could take notes on that if you wanted to. This leads into the next handout anyway. So the first example is just find log base b of b. So like, you know, we've done a few problems now where, like I've said, log base 7 of 7 equals what? And so the way that we've done it is we've called that thing x, and then we did the rearranging formula. It says log base b of a equals c, means the same thing as b to the c equals a. So if we rearrange this guy, then we get 7, this b, to that c equals this a. Well, that means that x has to be 1, which means log base 7 of 7 has to be 1. Well, let's try the same thing over here. If I call this x, I'll use a different color so we know what I wrote. Okay, and then I rearrange it. I've got the base b, so that's this part. And then it equaled x, so that's my power. So b to the x equals, and then the a term is what the whole thing ends up equaling. So that equals b. So that means that x has to be 1. So then, really, x is what we call the original thing. So log base b of b is always 1. So if you come across some problem now that says log base 3 of 3, you don't have to work that out. That's just 1. Log base 1.079 of 1.079, that's just 1. Okay? All right. That'll come in handy as we do more and more of these problems. Okay, so that's example 1. This is a big property of logs that people kind of use because it comes in handy a fair amount. Example 2 is asking you to somehow try to combine log base 4 of 5 and log base 4 of 10. And the mistake that a lot of students say is they say it's log base 4 of 15, which seems kind of logical, add the 5 and the 10. But it doesn't actually work that way. Of course it doesn't. That'd be too easy, right? So I'll show you how to figure it out. But really, you're just going to use the final property that we get out of it. But what I'm going to do is I'm going to call x log base 4 of 5. So the first term I'm calling x. So I'm going to say let x equal that. And we'll let y equal log base 4 of 10. So then really what I'm looking for here is what's x plus y, right? That's the same thing. Well, if I use that rearranging formula, so log base b of a equals c means the same thing as b to the c equals a. If I rearrange the first one, I'm going to get 4 to the x equals 5. And if I rearrange the second one, I'm going to get 4 to the y equals 10. Okay? Now what I'm going to do is I'm actually going to multiply these two things. So if I multiply those two things, I'm going to get 4 to the x times 4 to the y. And if I wanted to know what that equaled, well, it's the same thing as these two guys multiplied together. So it's going to be 5 times 10. So now what I've got is 4 to the x times 4 to the y equals 50, which is the same thing as 4 to the x plus y, right? Because I've got x 4s here and y 4s there, so together I have x plus y 4s. That equals 50. And now what I'm going to do is I'm going to use this formula again, this changing formula, and end up with log base 4 of 50 equals x plus y. That's when I rearrange it. Well, remember, x is this, and y is this, because that's what we set up in the first place. So then that means log base 4 of 50, whoops, let me scroll down a little, is really log base 4 of 5 plus log base 4 of 10. So it turns out this doesn't add up to be log base 4 of 15. It adds up to be log base 4 of 50. And the general rule is this. If you have log base b of some product, m times n, then that actually turns into log base b of n plus log base b of n. So you see it go both ways. Like if I said, what's log base 4 of 50, and I said, break it down into some smaller pieces, well, you could say it's, whoops, log base 4 is what we were working with. So this by the way, is a well-known rule for logs. So if I said log base 4 of 50, and I said break it down into a couple pieces, well, you could do the 5 and the 10, but you got to remember to add the log base 4 of 5 and the log base 4 of 10. Or you could break it down into two other things that multiply out to 50. You could have done log base 4 of 25 plus log base 4 of 2 if you wanted to. Right? There are other things you could do too, but I'm not going to worry about those. Okay. Another thing that comes up with this is like maybe you see some problem that says log base, let me use a different number. Log base 7 of 7x, and it says, you know, expand it and simplify it. Well, you can break up the 7x into a 7 and an x. So it becomes log base 7 of 7 plus log base 7 of x. Whoops. Uh-oh. Of x. Well, we just figured out that log base b of b, way up here, this thing always equals 1. So that first term right here is 1 plus log base 7 of x. So really, if I had this, you could turn it into that instead, right? And you do that basically if the directions say expand and simplify, which is what this next example says right here. Expand and simplify this thing. Okay, so that's going to be log base 3 of 9 plus log base 3 of x squared plus log base 3 of y. You can kind of see I'm extending the rule because now I'm saying it's 3 different things put together. Okay. Well, let's figure out what these things break down into. Okay, log base 3 of 9 you can actually work out, but we could do it using a small trick here. That's really log base 3 of 3 times 3. And then this is really log base 3 of x times x. And this is log base 3 of y. So this one's going to turn into log base 3 of 3, just this part, plus another log base 3 of 3. And this one's going to turn into a log base 3 of x plus another log base 3 of x. And this one just stays put, log base 3 of y. Well, I know that this equals 1 and this equals 1. So that turns into 2. And this, I just have 2 of the same thing. I've got 2 log base 3 of x. And then I've got a log base 3 of y right here. Okay. So this thing, if I expand and simplify, it turns into 2 plus 2 log base 3 of x plus 2 log base 3 of y. The idea when you expand and simplify is that the thing you end up with shouldn't have any exponents and shouldn't have any products on the inside. It should all be just simple terms on the inside of each log and then no powers. So, okay, hope that helps a little bit.